Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of complex numbers. And if I talk about the question that is given to us here from this topic, the question tells us that let z be a complex number such that absolute value of z plus 2 is equals to 1. And the further second condition that is given to us that says imaginary part of z plus 1 over z plus 2 is equals to 1 over 5. Then the question is asking me to figure out the value of absolute value of real part of conjugate of z plus 2. So that's the question asked to us. And if I talk about the answer choices that we have been given here, the options are 2 root 6 over 5, 24 over 5, root 6 over 5, 1 plus root 6 over 5. So we need to figure out which one of the answer choices is the correct answer for the question that is given to us here. So let's see how to solve this question further. So first of all, z being a complex number, it should have a real part and an imaginary part. So let's say z is x plus iy, where x is the real part, which is without I, and y is the imaginary part because it is with I. Now the question has two conditions. Let's try to simplify the two conditions. First one says mod of a modulus of z plus 2 is equals to 1. So modulus of z plus 2 is equals to 1 can be written as modulus of x plus iy plus 2 is equals to 1. That gives me modulus of x plus 2 plus iy is equals to 1. Now, once I have that with me, modulus of something means I have to just do square root of the real part squared and the imaginary part squared. So x plus 2 squared plus y squared equals 1. Squaring both of them or squaring both the sides gives me x plus 2 squared plus y squared equals 1. So I have my equation 1. So I have first equation with me in terms of x and y. X and y basically because two variables, I should have two equations for them to be solved. Let's try to get the other equation then. So the other condition tells me imaginary part of z plus 1 over z plus 2 is 1 over 5. So imaginary part of z plus 1 over z plus 2 is 1 over 5. So imaginary part of z is x plus iy. So I have x plus iy plus 1 and x plus iy plus 2 is equals to 1 over 5. The imaginary part of this is 1 over 5. So first let's try to solve only this much part and then we'll figure out the imaginary part of this entire complex number, whatever we get, and equate it with 1 over 5. So if I just try to solve for this one first, x plus iy plus 1 over x plus iy plus 2. So first of all, I can write this in the form of real parts together, imaginary part together. So x plus 1 plus iy and x plus 2 plus iy. Now, to have my denominator out of the imaginary part, I'll rationalize this. So rationalizing the denominator means multiplying with x plus 2 minus iy both the sides. Multiplying with x plus 2 minus iy both the sides, I have two terms to be solved here now. So these two terms get multiplied with each other. That leaves me with two brackets. So x plus 1 times x plus 2 plus I y x plus 2 minus I y getting multiplied with this x plus 1 and minus, because plus into minus, I get I square y square over. This leaves me with a plus b, a minus b. That gives me a squared minus b squared, which is I squared y squared. So from here, let's see what I get. I get from here x plus 1 times x plus 2. I have I, y, common from these two terms. So I'm left with x plus 2 minus x plus 1 minus I square is minus 1. So minus 1 into minus will become plus y square over. This gives me x plus 2 the whole square minus I square. I square is minus 1. So minus times minus 1 is plus. So y square. So I have this entire thing with me. Now, if I write my entire equation in the form of a complex number as real and imaginary part differently, because I want to have just the imaginary part of this idea and equate it with 1 over 5. So if I write it in the form, I can write this as x plus 1 times x plus 2. This is without I and this is also without I. So everything becomes real here and divided by the whole thing. So x plus 2 the whole square plus y square. This is your whole real part, and imaginary part if I see plus I y x plus 2 minus x minus 1. So this and this cancels. 2 minus 1 is just 1. So I y just 1 over x plus 2 the whole square plus y square. So I have this form. Now, once I have this form, the question tells me of this complex number, whatever is the imaginary part, equate that with 1 over 5. So this entire thing which is there, I'll equate that with 1 over 5. So this becomes y times 1, which is y, over x plus 2, the whole square, plus y square equals 1 over 5. So I have this second equation with me. X plus 2 the whole square plus y square. From the equation 1, I know it's just 1. So I'll substitute 1 into. So I'll put 1 into. So from there, I can get y over, this entire thing is 1 equals 1 over 5. So I've just used this x plus 2 the whole square plus y square, which is 1. So y over 1 equals 1 over 5. That gives me directly the value of y. So I directly get the value of y, which is 1 over 5. Putting that here, I can just get the value of x. So x plus 2 the whole square plus y square, which is 1 over 5 squared, which will be 1 over 25 equals 1. So x plus 2 the whole square equals 1 minus 1 over 25, making the denominator same and then trying to solve it and multiply with 25. So 25 minus 1 is 24 over 25. That's x plus 2 the whole square. Taking square root on both sides gives me x plus 2 equals plus minus root 24 over 5. And plus 2, if I take it on the other side, I directly get the value of x, and that is x equals minus 2 plus minus root 24 over 5. So I have this with me. So that's my x value, and this is my y value. So I have x and y, both of them with me. Now let's try to do the question. So I have my z, which is x plus iy, which is x, I have gotten that as minus 2 plus minus root of 24 over 5 plus I have gotten that as 1 over 5. That's my z, that's my complex number. Now let's try to solve this further. Question is asking me to figure out real absolute value of real part of conjugate of z plus 2. So first let's find z plus 2. So to find z plus 2, I already know z. This is my entirely z plus 2. So minus 2 and plus 2 goes away. I'm just left with plus minus root 24 over 5 plus I over 5. That's my z plus 2. Now if I want the conjugate of this, I get from here plus minus root 24 over 5 and plus I over 5. I can just write that as minus I. So I have gotten that as well. Now real part of this conjugate. So real part means I don't need the imaginary part with me. I'll remove this as it is. So I'll just get plus minus root 24 over 5 And the question is asking me to figure out absolute value of this real part. So absolute value, we know absolute value of anything will never remain negative. So it basically turns out to become positive and becomes root 24 over 5. And root 24, if you want to split it, I can just write that as 2 times 6 over 5. Because of two twos in the root, I can just take them out because square root of 4 is 2. So it becomes 2 root 6 over 5. And that, if I see, it matches with which answer choice? It matches with option A. So A becomes the correct answer for the question that was given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of using the concepts of complex numbers. So first, what we did is we had z as x plus iy. I put it in the two conditions. I got two equations in terms of x and y. I used both the equations to give me the values of x and y, and once I got that, I just found out what the question was asking for. That basically becomes root 2 root 6 over 5, which matches with answer choice A. So A becomes the correct answer for the question that was given to us here. I hope you have understood this. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well. Do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions that we are solving. Thank you.